Hello, this is the engineer of 7949S, and here's our Australia Nationals winning robot. So here's our robot explanation. We start with the chassis. As you can see, there's 36 to 48 on 3.25 wheels, which is like 450 RPM. This was originally a traction wheel, but we changed it out after Nationals because it was just fiddling around with it. You can see here we have the bearings used as like spacers for the cross brace because it's got like little notches in them, and then those things fit into the squares, so it helps square this to this and they keep it perpendicular so your robot doesn't fall apart or become a parallelogram during the competition. And in order to save some weight, we've used zip tie the bearings instead of like screwing them in. We also use a structural screw joint, which means on this side we have, I forgot what length this screw is, maybe a 3.25 or 3/8 inside an retainer to center it. On this side we have a 1/2 inch long standoff above my thumb inside the C-channel, and then we have this capstan here, and then there's a 2.5 inch screw that goes through this low profile bearing along the caps nut, and then it screws perfectly into the 1/2 inch standoff over here. And then after we screwed it, we tighten this caps nut without rotating the screw. This is how a screw joint works. I like it a lot because you don't need to like fiddle with 2 or 3 caps nuts to install it or like uninstall it. You just need to like have like a spanner and a screwdriver, and then you just undo this one screw and everything comes apart. I know some people will say, oh, it's because if you have 3 then it's better safety, right? But I don't think so, because if one caps nut out of 3 comes loose, then the entire screw joint seizes up. So it's actually better to only just have 1 caps nut, because you have 1 point of failure rather than 3. But it's not AND gate, it's more like an OR gate. If any of them fail, the entire thing fails. And then the orientation of these C-channels is a bit stupid because I was lazy. And then we've just got like some thin spacers from RoboSource so they can fit around these wheels. And then we have a high strength shaft bracing, and then battery fitted under here because low center of gravity, you know. Then our brain is actually in a stupid spot inside the robot. It's like inside here, and then the tanks are here, which doesn't make sense. And the reason why I did this is because I forgot that it's not supposed to be this way around. When I was installing the brain and managing the wires, I forgot that they were supposed to be closer to the back so they could be accessible. That's literally the only reason why. Now, since we can't really press the screen, we have this funny switch here. So we press this to use our Orton selector, like it toggles the Ortons. Not that complicated. Right, next we move on to the intake. So here's our mash loader mechanism. It has Tom the cat on it. That's the only thing that makes it work. These rubber bands, we use these rubber bands to tension this to the right angle. It works on hopes and dreams and nothing else. This rubber band is dead now. It used to work, but after 2 months it's dead. We just have one double acting piston here that pulls it up and pushes it down. It just works like any other scraper mech. And because I designed the robot badly, it doesn't exactly fold up. The idea is, if you look at it from this angle, this is supposed to hit here and it rotates into kind of this position. I don't know why it doesn't work now. It worked at Nationals, and then you would be able to see this very cleanly. We also have Jerry. One innovative thing about our intake is that our intake motor here, you can see there's an extra piece sticker. It's mounted under the intake. Then we have one chain from here going up to here, which drives the flaps. And then we have another one that goes from here to here, and there's a screw joint here, which our plastic intake is mounted on. And how these two sprockets, this one and this one, rotate together is that we use the brass insert to link the centers of these two on the screw joint. And then, so then this distance from here, this axle here to this axle here is always constant. So I don't need to make a chain tension or anything like that. And then there's this free spinning spacer, it's a bit hard to see, which just lets the chain roll past it freely. And then this entire chain assembly is sandwiched in between two pieces of plastic, which makes it really hard to break. It's like if you ram here, you won't be able to touch the intake axle. This never broke. Like, this entire assembly here, here, and here looks very complex, but it never actually broke once during practice or tournament. And we won nationals, so I think it's pretty good. Just a basic intake, the 5 flex wheels, some rubber bands, and we used a combination of latex tubing and rubber bands for the intake ramp. Moving on to the other side of the robot, we have the upper intake. So this motor is here, it powers this hood assembly. This is a bit heavy. So this is basically the rig-on hood. And then this drives this chain. It drives this chain, which drives this roller, which is obvious. But then it also drives this chain, which we have another screw joint here, where this sprocket is connected to this thing through brass insert again. And then here's the most innovative part. We have a PTO for the middle goal scoring. So as you can see, if I pull this gear out, then this assembly and this assembly aren't connected. So if I spin this won't spin. But if I put this in, then when I spin this through my hood motor, they spin together. This is done so that I can choose when to spin this. Basically what happens is I can intake a block. I know the robot's not on right now, which is kind of rare for robot explanations. And then if this PTO is engaged, then I can do this. And the rotation of this roller over here goes and forces it down and out into this middle goal scoring place. Okay, so the driver sent me the robot without the controller, so I'm currently operating it through the brain controls. So, as you can see, I can't run the roller too fast because all the rubber bands are broken from like after nationals. But as you can see, if the block goes into the hood while this is out, so the PTO is not engaged, it goes out the back, out the top part there. I can demonstrate this again. However, if we engage the PTO by retracting this piston, and this roller also spins, then it will come out the lower part. I think I'm holding the handle too close, but it should be fine. Yep, so that's basically our PTO. And the reason why we had a PTO is because the block, when it comes up the intake this way, it will first contact this roller, and then it will contact this roller. So if we chain them all both in the same direction as what the PTO does, if we chain them in the same direction permanently, then the block would only ever go up here and then go down here into the middle goal scoring part. But if we chain them always in the opposite direction, then it would be like basically always going up here and never down here. So we just implemented this PTO. And the way that this PTO works is that there's a 25mm piston mounted under the intake here, and basically the gear free spins on the shaft of this piston. Now, one very important detail is that it only spins, it only receives torque from the intake motor when it's in the retracted position, because if it did so in the extended position, then it would bend the shaft of the piston. Pretty good free spin. Oh, and another thing is that we have this solenoid, SMC solenoid here, which powers both this PTO here and also our wing. So our wing is double acting. There's a lot of people who asked us at Nationals, how did you get the wing to retract with so much force? Well, the answer is we just used double acting piston, which is supposed to be how you use it. They're linked together so that when this is extended, the PTO is in a state where the block will come out the top here through the long goal, and when the wing is retracted, it will come out through the bottom, which is middle goal, top middle goal. And the reason why we do this is that there's no way to tell at a glance. For example, if I was on this side of the robot and then I can't see the state of the PTO, right, I would have to rely on my memory to tell me whether I'd engaged it or not, which is not very reliable. So if we use this as an indicator, we can always tell at a glance whether our robot is in the middle goal or long goal scoring mode. There's no air in the robot right now, but yeah. This wing, we just made it out of 2 C-channels stacked together. I'd recommend you make it like mount a bit higher and also like horizontal by default, so it can score without you having to extend it and then retract it, because that works better. I just ran out of time to like make this wing properly when I was making it. And there's our funnels. Are just 2 pieces of plastic, and they're pushed out by this screw assembly here, and then we have this thing for like theoretical color sorting that we didn't get to. And that's about it for our robot explanation. I don't think there's much else to say. Oh no, there is something to say. This plastic piece is our middle goal aligner. I just cut it randomly, it doesn't really work. It vaguely works. And then here's a long goal aligner, which also only vaguely works. Our drivetrain should have been like done like this so that it funnels into the middle more, but whatever. I recommend you do this so it funnels better, because this is not very much like good at funneling. You'll also notice we don't have sleds because driver doesn't like them. That's the only reason why. And then we have these what are they called? Angle pieces here that prevent the gears from scraping the barrier when we cross the park. The reason why we don't have sleds is because like the reason why we can be confident with no sleds is because we designed this. We used 450 RPM, so this is like more than the height of this space from here to the ground is more than the height of the barrier. Then we kind of ruined it by like putting this here and this here and this here, but it works fine. We could hit some crazy parks during Nationals. Oh yeah, and then this piece here is made out of plastic because we realized, well, firstly we can, secondly, when the block was in the diagonal position of the greatest width and we had the 2 side by side, it would get jammed sometimes while we were using this C-channel. So we just replaced it with this because we had like a piece spare, and also it saves like a few grams of weight, so there's that. I think that's about it. Yeah.